All right, welcome everyone. Welcome to the Center on Religion in the Global East's second webinar in our series, Mapping Religion. The Center will offer 6 webinars throughout this year and next, all free and open to the public. Webinars feature top researchers throughout the world who are using spatial tools to advance the social scientific study of religion in East Asian societies, East Asian diasporas, and religions originated in East Asia that are spread throughout the world. This series is generously sponsored by the John Templeton Foundation and Purdue University. The center is currently working on data for Japan and Taiwan, and it's OSAGE, the online spiritual atlas of the Global East. So these currently house large data sets on religious sites in China, Korea, and Hong Kong. As I mentioned, soon will be Japan and Taiwan as well. So today's webinar features 3 papers that are drawn from this data set on OSAGE. Each speaker will talk for about 15 minutes or so, after which we will have 40 minutes of Q&A from the audience. So you may write your questions in the Q&A window during the presentations or save your questions for the end. This webinar is being recorded, and the 3 presentations will be put on the center's website, globaleast.org, in coming weeks. So without further ado, please help me welcome the first speaker, Dr. Joey Marshall, Mapping the Establishment of Protestant and Catholic Churches in China. Dr. Marshall.
Everyone, my name is Joey Marshall, and I received my PhD from Purdue and worked on this research while I was there. And I'm presenting co-authored research today that we've titled Mapping the Establishment of Protestant and Catholic Churches in China, circa 1949 to 2004. Jonathan, you can advance the slides. And what we're presenting here is a county level analysis of change in the number of Christian churches in China from 1949 to 2004. And we're utilizing a national geocoded data set of Christian churches in China, harvested largely from the 2004 China Economic Census. And what we find is that Christian churches in China grew more rapidly when they were located in counties closer to provincial borders than churches that were located in counties farther away from provincial borders. And we hypothesized that Christian church growth over time would cluster geographically around provincial borders because borders offer a source of security, especially for clergy facing political pressure or the threat of detention. And as we unpack the results and theoretical mechanisms, I want to foreground not only the importance of provincial borders in China as sites of religious change and innovation, but more broadly, this study speaks to how political boundaries can act as physical representations of power dynamics that shape the trajectory of all kinds of social phenomena, including, but not necessarily limited to, religious change. Slide. But I want to start by asking the kind of so what questions. Basically, what were our motivations for doing this research and why did we think the findings would be important? So first, one key theme we want to highlight is the importance of China in general and religion in China specifically for geospatial research. China is the world's most populous nation and one of its largest economies. But international academic geography has been criticized as overly focused on the US and Europe, with often limited applicability to non-Western contexts and sometimes few intellectual tools to engage a global audience. But China in particular has witnessed social change over the last century on a scale and with a rapidity unmatched almost anywhere else in the world. And religion has been a central and often underappreciated feature of this change. In terms of spatial research, attitudes and political action regarding religion have such strong regional variation across China that it's difficult to characterize a single national disposition toward religion. For instance, in some areas, especially those with a profitable tourist income, local and regional officials might hold a more tolerant attitude toward religious communities, whereas in other regions, especially those with an increasing number of churches or mosques, authorities may have implemented increasingly suppressive anti-religious policies. And spatial features like political borders turn out to be critically important to understanding the geographic characteristics of religion in China. You can advance the slide again. And I want to make one more note about borders in particular. because they hold a kind of paradoxical significance for geospatial research. On one hand, official borders are a default method of parsing space for analytical purposes. That's because administrative boundaries are ubiquitous in data that you get from various data providers, like from governments or other data sources. They always have administrative boundaries, and they're just kind of the default for analytical quantitative geography. However, the use of administrative boundaries can reify an allocation of space that is political, contested, sometimes totally unrecognized by locals. And especially since the emergence of cultural geography, spatial research has become much more sensitive to the power dynamics that underlie the official representation of physical space. The use of administrative borders can sometimes occlude the geographic distribution of cultural phenomena that are messy, that don't adhere cleanly to official borders. Nevertheless, our research serves as a reminder that administrative boundaries have a place in geospatial research because they represent a physical manifestation of power dynamics. In other words, we can see the power dynamics that underlie political borders as a feature, not a bug, of our research. In our case, official borders are key to understanding the geographic patterns of church growth. This is not because Christianity is somehow different in different provinces in China, but because border regions attract politically vulnerable religious groups who need to avoid persecution. Early on in this research, we suspected that churches closer to border regions might be particularly fertile grounds for church growth. And the reason for that is because in counties near provincial borders, it's easier for controversial ministers to avoid political pressure or police detention by crossing the border into a neighboring province. Police who want to chase them across the border need approval from the central government, which can sometimes be a substantial barrier. And we had some qualitative examples of this. One high profile example is Zhang Rongliang, the leader of one of China's largest house churches, the Fangcheng Church, who fled across borders many times. He was eventually arrested and sentenced to prison. But one of those prison charges included something like illegal border crossing. So borders were really key to that anecdote and to the crimes for which that leader was prosecuted. But really, beyond the kind of anecdotal or qualitative accounts, we wanted to look for broader empirical evidence of this trend, which is very difficult because of a general lack of data. So let me explain how we approach this question empirically. You can hop to the next slide, and let me say a bit about the data that we're using. Other people may give other details about our data if they're presenting on the same thing. But we began with a national data set of churches established in China between 1949 and 2004. We're able to geocode those religious sites to geographies. And the way we were able to put that together is kind of very hard data to come by. Is the team began by using the China population census as a kind of spine, but a lot of the establishment data are from the China Economic Census 2004, which is a register of economic establishments, but it includes about 73,000 officially registered religious sites distributed across nearly 3,000 counties and county equivalents like county level urban districts. Those establishments we were able to identify as religious sites and as Christian churches in particular by doing iterative text analysis on the names of those establishments. I'm not a native Chinese speaker, and I didn't do this part of the text analysis. Other people on the call can speak to this if you have questions, but the high level summary is we looked for linguistic variants of words that might indicate church or names of Christian saints like St. Paul, or denominations in the title like Seventh-day Adventist. The bottom line is linguistic variants that signaled Christian keywords helped us identify sites as Christian sites, and then we were able to geocode them to province, prefecture, and county. You can skip to the next slide. There are a few caveats with this data that I think are worth mentioning. First of all, because the core information is from an official census, only the officially registered religious sites were counted. So we almost certainly have an undercount. Other reports have shown greater numbers of religious sites. There was a report from Xinhua News Agency in 2009 that claimed a total of 130,000 religious venues. That's twice our number. But we're not surprised by this. We expect an undercount. First of all, because officially registered sites represent only the red market part of religious sites in China. In other words, officially recognized religious sites. Other sites in the legally tenuous gray market or the legally banned black market are not represented in our data. And even among officially registered sites, there are other reasons for undercounts, such as political pressure from lower level government leaders who may misreport or underreport counts of religious establishments for various reasons. But with all of these caveats, I want to note that, first of all, imperfect information is better than no information. And I think more importantly, if we can detect this trend of clustering around borders for church growth, and if we can detect that trend in the officially recognized churches, it's reasonable to imagine that unrecognized churches may be even more prone to this kind of clustering because their clergy are more likely to be controversial and to need the protection they might find in these border areas. So you can imagine this as a conservative test of the hypothesis that might, we don't know, but might be even stronger if our data extended to include the unrecognized religious sites. You can go to the next slide, and let me talk about our analytic strategy. We began with this geocoded data set of religious sites in China, identified the ones that were Protestant and Catholic in the ways I've described, and we aggregated those religious data up to the level of counties and county equivalents to calculate the county level church growth over time, which is what we used as the dependent variable or outcome in the regression models that I'll present in just a few minutes. Our models exclude counties located in any of the 5 ethnic minority autonomous regions, mostly because we expect geographic patterns to differ widely between the autonomous regions and the rest of China proper. The areas that we did test more or less coincide with Skinner's macro regions. Next slide. This map shows the density of Protestant and Catholic sites across a national map of China. And this is really useful for an initial snapshot of the distribution of Christian churches across space. A glance at this map reveals that Christian sites were concentrated on the East Coast and in the north central interior, with some other sizable clusters in other areas. What we can't get from this map, number one, is change over time, which I'll show in just a moment. And two, these data are not adjusted for population density. So the density of churches, to some extent, will follow population density. If you look on the next slide, you can see a scatter plot where we're showing Christian growth in China over time. These are the sites we identified and geocoded as Protestant or Catholic sites. And what you can immediately see is that Christian growth in China occurred largely after 1979. Few Christian churches were established between the early 50s and late 70s. During those years, especially from 66 to 79, the Chinese government was suppressing religious activity harshly. However, after lifting the religious ban in 79, Christian growth expanded dramatically. This figure suggests that Christian sites in our data were established at an average rate of about 2 to 4 new churches per county every 10 years between 1980 and 2004. If you go on to the next slide, we can show you how we calculated border regions. We operationalized border regions as points where provincial borders intersect, and we calculated nearness to a border region, our key predictor, in 2 ways. The first, we estimate the distance in meters from each county seat to the nearest provincial border. And second, we estimated the distance from each county to the intersection of 3 or more provincial borders, which we think of as border regions. I can say more about how we made these calculations if you want to ask during question and answer time. But for now, I want to be conscious of time and move on. So you can go on to the next slide. And I just want to show our estimation equation. I won't belabor some of the details here, but we fit random intercept negative binomial regression models where our outcome, which is growth in Christian churches, was regressed on a bunch of fixed effects for county level predictors and a random intercept. But crucially, we fit a growth curve term, an interaction between time, which we operationalize as years, interacted with our key predictors, which is nearness to provincial borders. And we use this to answer the key question: did Christian churches near provincial borders experience more rapid growth than Christian churches farther away from provincial borders? And we'll show those results on the next slide. This visualization is showing a plot from the estimation equation that I just showed. And here we're plotting this growth curve term that I showed to answer the question of whether churches were established more rapidly in counties closer to provincial borders. The vertical axis here is the predicted number of new Christian churches per county. The horizontal axis here represents time. And you'll see two plots. One plot line for counties that are very near a provincial border, that's the red plot line. And another plot line for counties far away from a provincial border, that's the blue plot line. Beginning in the 1970s, these lines began to diverge, suggesting that counties near to a provincial border were experiencing, on average, a more rapid establishment of new churches than counties far away from a border. I'm not showing all the coefficients here. I can later if you want to ask about them, but in general, for every 1% increase in distance to a provincial border, we predict a 0.16% decrease in county level church growth. There's an easier way to think about this. If you just skip to the next slide, the easiest way to think about this is in this statement: a county twice as far from a provincial border than average would expect about 16% less church growth than the average county in our data. Okay, you can advance 2 slides and let me just wrap up with some conclusions. Christian churches in China grew more rapidly in counties closer to provincial borders than in counties farther away. That's the key empirical takeaway of our research here. And these findings are congruent with prior literature depicting border zones as sites of resistance and social change. We hypothesized that Christian church growth would cluster geographically around borders because of the political protection offered by border zones. And this finding really highlights the importance of political boundaries as physical manifestations of power dynamics that in some cases make it appropriate to use official borders. They're used almost everywhere in analytical research, sometimes more or less thoughtfully. But in our case, the official borders are really a key feature of the geographic distribution of religious characteristics around China. There are a lot of pointers here to future work that might explore generalizability to other religious groups in China, or really to other politically marginalized groups in other kinds of social and national settings. But for now, I'll just pause there, turn it over to my fellow presenters, and I look forward to any questions you might have at the end. Thank you.
Hey, thank you so much. That's a wonderful presentation. It's our second speaker.
I think you're muted. I don't hear you.
You don't hear me. Can you hear me now?
No, I can't hear. It's okay.
It's okay. Okay, good. It's we'll make it through all the technical difficulties, I promise. Next up, Dr. Yunping Tong, Religious Geography and County Level Sex Ratios in China. Dr. Tong.
Can you hear me fine?
Yes, that sounds great.
Yes.
Okay, great. Good evening and good morning to some of you. My name is Yunping Tong, as Johnson just introduced. Like Joey, I also did my PhD at Purdue University and studied sociology of religion, but my research focus was on how religion shapes fertility preference and decisions in China. And today I'm going to present a study that is part of my dissertation, and it was published in a journal in 2021. It's titled Religious Geography and County Level Sex Ratios in China. During this presentation, oh, I should turn my camera on so people see I am here. Okay. So during today's presentation, I will focus heavily on the data and analysis part. I got interested in this topic when I was writing about the demographics of China using county level census data. And I noticed that China's sex ratio among children was highly male biased, strongly favoring boys. And here's a graph of the sex ratio measured by the number of boys per 100 girls ages 0 to 4. And we can see that the average ratio from the 2000 population census was 116. This is much higher than the biologically natural ratio, which is 105. And this male bias in the sex ratio among children means that girls were missing or disappeared from the population because they, due to some discriminatory practices, such as female selective abortion and female infanticide. And oh, my camera is still not on. Sorry about that. Anyway, I will move on. And Admittedly, China's sex ratio has improved since then, but only marginally. In the most recent 2020 census, there were still 114 boys per 100 girls. It's still far above the normal value. And research suggests that China's child sex ratio became noticeably male biased since the implementation of the one-child policy in the 1980s. And scholars have identified two main causes for this skewed sex ratio among children: selective abortion as a primary cause, and the Confucian tradition of son preference being the root cause. In the Confucian tradition, I think people here may be familiar with that sons are preferred for several reasons, and one of them is that only sons are believed to carry on the family line. And under this one-child policy, parents who preferred having a son over having a daughter were likely to engage in practices including aborting female fetuses or mistreating girl babies, which subsequently led to a skewed sex ratio in the society. And with identifying the Confucian tradition as the root cause or the underlying driver for the imbalanced sex ratio, scholars have been focusing on mostly economic factor, and they find that economic development tends to bring a balanced sex ratio among children, and because it tends to weaken the Confucian influence of son preference. And but different from the previous research, this study will take a new approach and brings in religion as a key factor to explore religion's linkage with child sex ratio. Research suggests there is a causal relationship between religion and sex ratio. Specifically, a local religious culture can indirectly affect the sex ratio through shaping individual values and attitudes toward son preference and abortion. There's two main causes for an imbalanced ratio among children. In this study, I examined the relationship between the child sex ratio and the religion's presence for each of China's 5 officially recognized religions. And among the 5 religions, we know that Buddhism and Taoism, often referred to as traditional Chinese religion, they are highly intertwined with the Confucian tradition. And unlike the other 3 religions, they generally agree with the idea of having sons to continue the family line. Therefore, I expect to find that child sex ratios in counties or in areas with a greater influence or presence of this Chinese religion are more male biased. The remaining 3 religions, Protestantism, Catholicism, and Islam, are typically known as Western religions in China. And because their teachings tend to challenge the Confucian tradition, including son preference, and they particularly emphasize opposing abortion. So I expected to find that a greater presence of Western religion is correlated with a less male favoring child sex ratio. Like Joey, I also used the census data for analysis, 2000 identical data set, 2000 county level population census for the sex ratio among children, and 2004 economic census for information in the religion in the county, for religion information in the county. And the religion influence or religion geography in the county is measured as the number of officially registered sites, including temples, churches, and mosques per 100,000 people. I also took the logged value to reduce the right skewness in the distribution. I create a religion presence variable for all 5 religions. The data may seem a little bit outdated, but the 2004 is the first, and it is still the most recent one that provided information on officially registered worship sites in all counties of China. And I also controlled for several variables, including GDP per capita, urbanicity, migration, ethnicity, and birth policy. I can talk them in detail if you are interested. Let's look at our core predictor, religion. So here's a map showing the number of registered worship sites by county, with each color representing a religion. As we can see, Islamic mosques here in green, there are many in the northwestern of China, while Buddhist temples in yellow, there are many in the south. And Protestant churches seem to be seem to have a strong presence in the central and southern parts of northern part of China. This distribution of region size is interesting, but because it's not the focus of this project, I will not go into details. Let's move on to our dependent variable, county level child sex ratio. In this map, red color represents strongly male favoring sex ratios that's above the national average of 116, and green indicates balanced or even female favoring ratios. And from the map, you can see that Western areas, they tend to have more balanced sex ratio, while those areas in the South, their ratios tend to be highly skewed. And the variations across regions suggest that the distribution of our dependent variable may not be random. Since this is our dependent variable, we do need to see if the pattern, this spatial pattern, violates assumption of independence, and we need to test for the spatial process before running any regression analysis. I use Morris I index to determine whether there is a significant spatial pattern in the distribution of county level child sex ratio. Morris I is a measure of spatial autocorrelation, which is how one object is similar to others surrounding it. And its value ranges from -1 to +1, with -1 indicating perfect spatial dispersion, that neighbors are all different, while +1 means perfect spatial clustering, that neighbors are all similar. And the Morris I value for our dependent variable is 0.6, meaning counties with highly imbalanced sex ratios tend to neighbor each other, so do counties with balanced or less male favoring ratios. As we can see the map, there are many high value clusters as well as low sex ratio clusters. But what caused such clustering in space? The answer to this question is very important because it determines how we will adjust for spatial pattern in our model to specify it as a spatial lag model or an error term. According to the literature, such spatial clustering can be attributed to the process of either dependence or spatial heterogeneity. Spatial dependence, it refers to a contingent type effect. I mean, COVID is a good example. It spreads geographically, and sickness in one region is usually responsible for that in the neighbor areas. So in such a case, spatial lag model is recommended. By contrast, a spatial heterogeneity, the variations across region are mainly due to exogenous factors such as climate, culture, or demographic diversity across areas. My understanding of this process of spatial heterogeneity is that it applies to the case where we couldn't pinpoint what or which factor best explains the spatial variations across region. And for such case, spatial error model is preferred. So now we need to decide which spatial process is primarily responsible for the variation, for the clustering in our dependent variable. Unfortunately, we don't have established literature addressing this specific matter, but we could reasonably assume that it possibly not the contingent type effect. But fortunately, there is a neat statistical procedure to help us determine and confirm the type of spatial process and choose between a spatial lag or error model. It's called the Lagrange multiplier test, which is available through this Geoda software. It essentially tests both models and to see which model fits which spatial term fits the data better. And our results show that spatial error model, they consistently return large values, so they are preferred for our analysis. Okay, let's move on to the final results. For this webinar's purpose, we are going to focus on the last two columns, models with all controls and the final model with the spatial patterns adjusted for. And let's look at the first controlled model. And after control for all demographic factors, first of all, consistent with prior studies, economic development, log GDP per capita, indeed has a balancing effect on child sex ratio. Secondly, let's look at our core religious predictors. 4 of 5 of the predictors are statistically significant, and they all have a very low p-value. The only insignificant one is the logged number of Protestant churches. And then let's look at our spatial model with spatial patterns controlled for. Compared to the previous model, we notice that the effect size for all our core predictors all shrank significantly, which means that some of the relationship between the logged region size and the dependent variable is actually due to the spatial pattern in the county level child sex ratio. And notice that the coefficient for the logged number of Catholic Church is no longer statistically significant after considering the spatial term in this county level child sex ratio. Nevertheless, we cannot say that the presence of Buddhist temple, Taoist temple, and Islamic mosques, they remain statistically significant associated with our county sex ratio, and with control for all other factors, a greater presence of Buddhist and Taoist, Buddhist and Islamic mosques, Buddhist temples and Islamic mosques is associated with less male-biased sex ratio, whereas a greater presence of Taoist temple is correlated with a more imbalanced sex ratio. And based on the analysis, we can now safely and confidently conclude that religion is a key factor understanding child sex ratio in China. And there is still a meaningful and statistically significant linkage between religion, measured as a logged number of officially registered worship sites, and child sex ratio in the county, even after controlling for the spatial process. And of course, like other studies, there are some limitations of this one. One major issue is our dependent variable, that our measure of registered worship site may not represent the actual religious influence in the county, because it doesn't capture any unregistered sites. I'm not going to bore you with all the details. Finally, I assume you are interested in working with religion sites data, so I included a couple of resources on spatial regression that I found very useful when working on this project. One is Geoda. It's a free open source software, and for this project, I used this software to run Moran's I index and spatial process test. And I also found these 2 books on spatial analysis super helpful. They included detailed introduction of spatial analysis and the proper method steps of working with spatial data. Here's my email, and if you have questions, feel free to email me. Thank you.
Hey, thank you so much, Dr. Tong. That's wonderful. All right, many questions, but keeping them in the back of your mind, or you're welcome to put questions in the chat if you want to go ahead and give the speaker some time to think about your questions, and we can discuss those. Either way will work. Our third and final presenter is Dr. Brian McFowle, Local Religious Environments and the Physical Health of Older Adults in China. The floor is yours. Thank you.
All right, how's that?
Yes, it looks great.
All right. Okay, so first of all, it's super fun for me to get to share the stage. Well, I guess it's not a stage. I guess it's the screen with Joey and with Tong. So I'm really glad to be here with all of you, and I'm excited to get to share some of my research with you. What I'm presenting today is from a chapter of my dissertation about the effect of local religious environments on the physical health of older adults in China. And since the emphasis of this webinar is methodological, I'll spend most of my time walking through the data, methods, and results of the project. But just to briefly set up my analyses, I want to show you a couple of maps that I will think will give you some theoretical background to the project. So the map on the left shows variation in China's prefecture level mortality rate, just as an example of variation in health outcomes. And the map on the right shows the predominant religion in each of China's prefectures. And my project connects these two maps by asking whether the religious characteristics of place impact the health outcomes in that place. Now, we're typically used to thinking about religion as something that belongs to an individual. But here I'm conceptualizing religion as an ecological characteristic, as a feature of a social environment. And that feature would influence both individual and community level outcomes because of how it shapes the social relationships, the social norms and values, behaviors, resources, et cetera, in that area. So the basic theoretical idea is that the demographic presence and socio-cultural influence of religion in a local social context, right, the religious environment, has effects that are actually independent of an individual's religion. And so for this project, I'm examining how that religious environment impacts health outcome. So the specific research question for the analyses I'll be presenting today is that how is the religious environment associated with individual physical health outcomes of older Chinese adults? And there are a couple of sub-questions here that guide my analyses specifically. Like, how is the overall presence of religion in prefectures associated with physical health? Does the association vary by religion? And here I've got the 5 major religions in China. And then does the association vary between adherents and non-adherents of each religion? So that's another question I'm looking at. And so to answer these questions, I'm connecting data, emerging data about the religious environment in Chinese prefectures with data about the health of individuals living in those prefectures. And obviously, just like Joey and Tong, data for my focal independent variable, the religious environment, are from the Online Spiritual Atlas of China, this same 2004 economic census that they've mentioned. And to measure the religious environment, I'm using a standardized count of religious sites for each religion in China's prefectures, right? These administrative subdivisions of Chinese provinces. So, for example, in each of China's prefectures, I'm calculating the number of Buddhist temples per 100,000 people. And I do this for all 5 of China's officially recognized religions: Buddhism, Catholicism, Taoism, Islam, and Protestantism. And as a side note, I'm using a log transformation of this variable in the models because of how skewed the data are. And so what this variable represents to me is how concentrated a religion is in an area, which I think is an indicator of how influential that religion is in the social life of that area, and therefore potentially on the health of the people living there. And then to measure health outcomes, I'm using survey items from the Chinese Health and Retirement Longitudinal Study, or CHARLS. And this is a nationally representative health survey of Chinese residents 45 and older. And in this presentation, I'm just presenting my work on self-rated health as the primary dependent variable. And I'm limiting my analyses just to individuals who are 60 and older. And this variable is also coded into 4 ordered categories of poor, fair, good, and very good self-rated health. My analyses also include a variety of control variables, both at the individual and the group levels. And these are variables that I think are important factors to account for in this relationship between the religious environment and health. As you can see from this slide, I've tried to present it in a way that makes sense, that these data are clearly nested, right? The people in this data set are clustered. So there's this multi-level structure to it that's important in terms of how we conduct the analysis. So there are prefectures at the highest level, and this is where I'm measuring the religious environment. And then the Charles survey, it sampled individuals in specific communities. And then in addition to sampling individuals in these communities, they also surveyed individual respondents and their spouses if they had a spouse and the spouse was available or willing. And so there's a household level to this data as well. So that's 4 levels, right? About 7,000 individuals from 5,200 households in 378 communities in 121 prefectures. So this is the structure of this final analysis data that I'm using. Now, ideally, I could have used a smaller areas of analysis instead of prefectures. I would have preferred to use something like counties, like Tong did, or townships, or even neighborhoods, these communities that these people were sampled in. But the publicly available versions of the Charles survey only identify the respondents' prefectures, nothing more specific like a county or community. So this is a bit of a limitation. The data is there for the religious sites, but not for the health items. And so I went with prefecture, which is what we have here. Now, because of the nested structure of these data, my analyses need to account for how these individual respondents are clustered at these different areas, at these different levels, I mean. And so I'm using multi-level regression models. But also, because my dependent variable is categorical, these are multinomial logistic regression models as well. So it's kind of a mouthful to say. They're multi-level, multinomial logistic regression models. Also, these models are random intercept models, and they actually account for all 4 levels of the data. And likelihood ratio tests that I ran indicate that a 4-level model, actually including all 4 levels, or specifying all 4 levels, actually fits better than 2 or 3-level models. And that's because of that clustering. It makes it more difficult to run and converge and all that good stuff in the calculations, but this is what the tests indicated. So on to some results. To present the results here, I've calculated predicted probabilities from these regression models, and then I've graphed them. The tests that I discussed were conducted using average marginal effects, and I could talk about that a little bit later if needed, but I don't think it's necessary to get the gist of what these results show. So the graph here, it shows the predicted probabilities of being in each category of self-rated health, with the total number of religious sites in Chinese prefectures as the focal independent variable. What's the overall effect of the presence of religion in prefectures? What does that affect on self-rated health? And the predictions from this model suggest that the overall religious environment of prefectures does not affect individual self-rated health. Notice that the predicted probabilities of respondents reporting each level of self-rated health does not significantly change as you move from left to right, as the total number of religious sites increases. These lines are more or less flat. So for example, as the number of religious sites increases, probabilities of reporting good and very good health, those 2 bottom lines, they stay at about 0.1 each. And it does seem there might be some slight changes for the poor and the fair health lines, but these changes are not actually statistically significant. So this means is that if there is a connection between the religious environment and health, then it is religion specific. It's not an overall thing. It's maybe a difference between religions, which is the next thing I examine. Whether the associations between the religious environment and self-rated health actually vary by religious group. So The graph in the upper left is the same graph we just looked at. I put it there for some comparison. But the other 5 graphs are all from a single model, which test whether there are associations between the number of sites for each religion and then those categories of self-rated health. Just as a helpful interpretation tool, the lightest color shade in each graph is poor health, and the darkest is very good health, the highest level of self-rated health. And what we see is that different religious groups do indeed have different associations with self-rated health of older adults. And I know there's a lot of information on these graphs, so I'm going to first outline the top line takeaway, and then I'll dig in a little bit more. The presence of Buddhism and Islam have an overall negative association with self-rated health. And the presence of Taoism and Protestantism have an overall positive association with self-rated health. So what this means is that as the number of Buddhist temples and Islamic mosques increase in a prefecture, older adults in those prefectures report worse levels of self-rated health. And as the number of Taoist temples and Protestant churches increases, older adults report better self-rated health. For Catholicism, it's not conclusive, which I'll touch on in a moment. So let's zoom in on Buddhism as a quick example to explain a little bit more what's going on here. An increase in the presence of Buddhism is associated with a lower probability of reporting good and very good health, those 2 darker lines, and a higher probability of reporting fair health. This is the line at the top. And if we compare the lines for good and very good to the line for fair, we see that what's actually happening is that as the number of Buddhist temples increase, people are moving out of the good and very good health categories and into the fair health category. The probability of people being in those categories moves to that other category. So this is a net negative effect. They go from the good and very good into fair. The poor line is not statistically significant here. And looking at the fair line, again for Buddhism, the probability of reporting fair health in prefectures with no Buddhist temples, right, we're 0 on the x-axis. Probability of reporting fair health in an area with a prefecture with no Buddhist temples is about 0.5. But then the probability of reporting fair health in prefectures with the most number of Buddhist temples in the data set is 0.63. So that's a jump of 13 percentage points across the entire range of Buddhist temples. And we could do something similar for good and very good, and you can see how it decreases across the range. So jumping back to this graph, looking at Islam. Islam is very much like Buddhism here. There's a net negative association with self-rated health. So as the number of mosques increase in an area, individuals are less likely to report fair health and more likely to report poor health. So they were never very likely to report good and very good, but they switched from fair to poor here. And then in contrast to Buddhism and Islam, the predicted probabilities for Protestantism and Taoism indicate a net positive association. So more Taoist temples is associated with lower probability of reporting poor health and a higher probability of reporting good health. And as the presence of Protestantism increases, respondents are less likely to report fair and more likely to report very, very good. Those are both net positive effects. Now, Catholicism is interesting here because there's only one statistically significant effect. More Catholic churches associated with a lower probability of reporting good health. And because none of the other categories are statistically significant, we can't determine whether the movement out of the good health category is into very good, which would be a positive effect, or fair and poor health would be a net negative effect. Very quickly, I also tested whether those associations might be different for adherents and non-adherents of these different religions. And I did that using cross-level interaction terms between the number of sites for each religion in prefectures and the religious identities of the individual respondents. So the Charles survey included a survey item about their individual religious identity. So I use interaction terms to test that. And so what this does is allows me to test, for example, whether the presence of Buddhism in Chinese prefectures is different for Buddhists than it is for non-Buddhists. And in short, these interactive models don't show any evidence that the effects I've just been sharing are different by the religious identities of the individuals. So this suggests that the effect of the religious environment on self-rated health is no different for religious adherents than it is for non-adherents. So just quickly to summarize and wrap up, a greater overall presence of religion in Chinese prefectures does not appear to be associated with self-rated health, right? The total number of sites in a prefecture. And this suggests that a religious environment doesn't have a single overall effect, which I wouldn't have quite expected it to have. But in terms of separate effects by religious groups, which is what I would have guessed would happen, we see that a greater presence of Taoism and Protestantism is associated with better self-rated health among older adults. And in contrast, Buddhism and Islam is associated with worse self-rated health among older adults. And again, these associations are present regardless of the reported religious identities of the respondents. I do want to mention a few limitations about this particular analysis. The first thing is I think most all of the measures could be approved in future work. I think it's a question about how well standardized number of religious sites, which I'm using here, adequately captures the presence and influence of religion. Just because there's a religious site there doesn't mean it's influential or has a strong presence. There may be many other indicators of that. Also, self-rated health is a pretty subjective measure of health. And so maybe what these analyses are showing is that the religious environment impacts how respondents rate their health, and maybe not as much how these presence of religion actually impacts their actual health. So it may impact ratings of health rather than actual health. And additionally, there's a spatial component to these data, which is what Tong was presenting on. And I'm not accounting for that in these analyses. I'm accounting for the nesting of individuals and families and communities and prefectures, but it doesn't account for the possible effects of neighboring prefectures, the religious environment of a neighboring prefecture on health. So that's a spatial aspect that I don't adjust for here. I'm not sure methodologists have worked out how to perform multi-level, multinomial logistic spatial regression models. I think it'd be quite complex and difficult to run. And then finally, I think the mechanisms responsible for these associations are kind of a black box. There's a lot of work to be done to try to figure that out. And they're likely to be different for different religions, include a whole host of things that I don't have time to discuss here, but that's future work. So I'm going to stop there. I'm happy to help answer questions, but thanks so much.
Awesome, thank you. That's a wonderful end to our three presentations. All right, well, thank you all for being here. This is a wonderful time. As I mentioned in the comment, please check our website. If you're not on our mailing list, the email is there. You can email us and join our mailing list. This webinar series will have at least 6 parts. So the third part will probably be later in the summer or very early in the fall. So be on the lookout for that. Yeah, it's